Hey, good morning, everyone. All right, so for today, we're going to keep building upon what we know about solving and what we know about lines on graphs. And so you're going to see here that we're going to solve for a point of intersection. And we can think of that in two ways. It's a point where two lines cross. I've asked you to look for that before. But more recently, think of it as being a solution to both equations. So just like 2 days ago where I said, which of these points is a solution? And then you tested algebraically and looked at the graphs and saw that any points that were on the line were solutions. Well, we're basically doing that, but we're saying, what is a solution to two different equations? So we can look at it on a graph, or we can solve for it algebraically. So for the first one, we're going to look at the graph first. So here I've got two lines. I've got y equals 3x plus 4, and I have y equals negative 2x minus 11. So when I think about that, like any point on purple here, this is a solution to purple only. Any point on black here is a solution to black only. However, there is one point that they share in common. In this case, the point negative 3, negative 5. That point is the point of intersection, or the point that's a solution to both equations. So keeping that in mind, I want us to focus now on how do you solve for that algebraically. All right, and so if I have two equations and they're both equal to y, we're going to call this the equal values method. And this has to do with the fact that both equations are equal to y. So when I want to solve for the point of intersection algebraically, I'm going to take the expressions that they're equal to, and I'm going to say, here's 3x plus 4 equals negative 2x minus 11. And then this is something I know how to solve. I can do operations to both sides. So remember, there's 4 ways you could start. I like to take care of the x terms first. So here I'll have 5x plus 4 equals, this will be 0x, so only negative 11 will be left. Take away 4 from both sides. Get 5x, these will be 0, equals negative 15. And then finally I can divide by 5, and I've got x equals negative 3. Cool. So if you notice, this x equals negative 3 perfectly matches the negative 3 from the graph. But the question is, how do we get this negative 5? Well, now that I know that x equals negative 3, I'm going to prove that this works for both equations. So in other words, I'm going to say, let's take our first equation. But now I know that x is negative 3. So we're just going to do 3 times our negative 3 plus 4. Y equals 3 times negative 3 is negative 9 plus 4, which will be y equals negative 5. Which, once again, notice how that y value is negative 5. But I only use the first equation. My goal is to show that it works for both equations. So what about this one? So we can do the exact same thing. We can say, what if x is negative 3 in the other equation? So now we get y equals negative 2 times negative 3 will be positive 6, minus 11. Y equals negative 5. So notice how in both cases, because y is the same value, I know that my solution here was correct. So for shorthand, I'm going to say for point of intersection that it's negative 3, negative 5. So all I'm doing is proving that if I set these two things equal to each other using the equal values method, when I solve, I get the x value that's part of my point of intersection, and that x value results in the same y value for both original equations. So I must be right. Therefore, my x value is -3 and my y value is -5. So just in case you need that reminder, remember it's just x, y. And one more time, that's backed up by the graph. All right, so that's pretty straightforward. It builds on what we've already done. Now I'm gonna demonstrate a case that's a little bit, well, it's not necessarily different. We're gonna use the same techniques. The only difference is most of our lines, when we put slopes in, are in fraction form. So here, notice how I have 3/8 and 7/8. We haven't focused much on fractions in terms of solving yet in class, but that's about to change. So I'm going to use the equal values method again. I'm just going to say, when is this expression equal to this expression? Looks good. All right. And for today, any of you who choose the practice option, you're going to simply have fractions with common denominators. So notice how both denominators are 8. This is good news for us because it means we can just directly subtract them. So I can do solving like normal. It's just I'm taking away a fraction from both sides. Oops, jeez. All right, and so remember the property of fractions is that in this case, they're going to be 0, leaving me with 9. But 7/8 minus 3/8, remember when I add and subtract, the denominator doesn't change, only the numerator does. So in this case, 7 minus 3 is going to be 4. So that's it. Here, then I'll keep solving like normal. Sorry, there's a lot of 8s in this problem. All right, so here's where things get a little bit different. We're going to talk a couple properties here. So whenever I see a fraction next to a variable, it's totally okay for me to imagine that this variable is actually in the numerator. So I'm going to think of this as, instead of 4/8 x, I'm going to think of it as 4x over 8. My denominator is 8. This really means 4x divided by 8. So whenever I see a fraction and I don't want it anymore, since it's divided by 8, I can just multiply both sides by 8. So just like here, when I have a positive 3/8 and I subtract from both sides, it's gone. Here, if I'm dividing 8 by 8, but then I multiply by 8, that's going to eliminate my denominator. So 8 times 8 is going to be 64, equals, my denominators have been eliminated, leaving me with just 4x. So if you want extra proof there, when I think of 4x over 8 times 8, I'm really thinking of this as 8 over 1. So 4x times 8 really is just 32x, and 8 times 1 is 8. What's 32 divided by 8? That happens to be 4. So notice how this property of fractions results in something that's reducible to the whole number that I got in this case. So this is the longhand. This is the shortcut, that whatever my denominator is, if I multiply both sides by that, they'll eliminate, leaving me with no more fraction. All right, with that said, my last step now, if I want to get x by itself, is divide by 4, just like normal. And in this case, I get x equals 16. All right, so there's my x value. Now the question is, what's my y value? So same thing as before. take one of the original lines. So I'm taking this one. The x value that I got was 16, so I'm going to replace x with 16. So once again, I'm trying to do a fraction times a whole number. So I'm going to think of this as 16 over 1. So 3 times 16 is going to be 48. 8 times 1 is going to be 8 plus 9. 48 divided by 8, thankfully, is a nice whole number. That's 6 plus 9. So I'm going to get y equals 15. All right. So here, I'm now saying that my point of intersection is 16, 15. That's a terrible 5. Now, the reality is, if I wanted to check this, I could put 16 into this equation also, just to verify that I also get y equals 15. In this case, that'll totally be true. So I'm just going to do shorthand. I'm just going to say that second equation would be this. And I'm going to tell you, so you feel free to verify this for yourself later, but I'm going to tell you that this also is going to come out to y equals 15. So they're the same. So one more time, if I work this all the way out, just like this one, you would see that it comes out to this. I'm just saying, if I do this, this will be the final result. Feel free to check me. But more importantly, if I open up these two lines, notice, sure enough, that our two original equations, when graphed, meet at the point 16, 15. So this is just me verifying my answer graphically. All right. And then finally, I'm going to verify one more time that this strategy works. And the only difference here is that I threw in a negative fraction just to make sure people are comfortable with that. So I'm going to work through this one quickly. It's a video. Feel free to pause and go back as much as you want. But this is just one final verification. So once again, I made sure that you have like denominators, so 3 and 3, so we don't have to worry about the fraction having unlike denominators. If you're doing the challenge, you will have to worry about that, so just think about what it means to have a least common denominator. All right, there we have it. So it was a negative fraction, so same rules apply. I just got to do the opposite. So these will be eliminated to leave us with 12. 2/3 plus 8/3. Remember, denominators don't change when I'm adding or subtracting them if they have like denominators. So that just becomes 10/3 plus 8 plus 8. Here's 20 equals 10 over 3x. So once again, I'm down to my fraction next to x. So I'm going to think about this instead of 10/3 x as 10x over 3. Since I'm dividing by 3 here in my fraction, I'm just going to multiply both sides by 3. 3 times 20 is 60, leaving me with 10x. Some of you can probably already see what my answer is going to be, but if I formally divide, I'll get x equals 6. All right, so once again, here's the x value. Don't forget to find your y value. So in this case, I'm going to use the second equation just to be different. So let's do 2 over 3x minus 8. Now I know that x equals 6. So let's throw in 6. All right, so 6 times a fraction, once again, think of it as 6 over 1. So 2 times 6 is 12. 3 times 1 is 3. So I have 12 divided by 3 now, which is 4, minus 8. I get y equals negative 4. All right. So I'm thinking that my point of intersection is 6, negative 4. Let's go check the graph. So here are my original equations. Sure enough, check it out. 6, negative 4, that's where they cross, so I know I'm good to go. And if you had checked the other equation, you would have gotten that same thing, that negative 4. So my final answer for the point of intersection is 6, negative 4. That's it. All right, so during today's work, feel free to open up a regular Desmos graphing calculator if you need to back up your work. You'll have fractions. Like I said, if you're doing the challenge is really going to come down to you'll have unlike denominators, which you'll have to adjust for before you can solve. But please reach out if you have any questions. Otherwise, good luck.